video, I'm going to be dealing mostly with ratio theorem. So ratio theorem, I'm going to be doing calculations involving solving simultaneous equations, but one will be a Cartesian form and one will be the equation of a plane. So out of that, with the ratio theorem, for example, if I have A all over B, that this is equals to C out of D, that this is equals to K. So out of that, I know that A out of B, which would be equals to K. I know that out of that, I can make A equals to B, K. I take this as 1. At the same time, if I make, for example, I take C out of D equals to K. And therefore, C would be equals to D, K. Now, suppose I add both of these. That I have, let's say, if this was my second equation, and I come here, say that equation 1 plus equation 2, that I would have A equals to B, K. I'm having C equals to D, K. And therefore, after adding this, I'll find that I'm going to have A plus C equaling to B, K plus D, K. Therefore, AC plus C would be equals to K into B plus D. And therefore, A plus C all over B plus D all over B plus D. This going with that, and therefore I'll have A plus C all over B plus D, which would be equals to K. So you find that this theory, actually, if I compare from up here, that means that I have A plus C all over B plus D, which would be equals to still K. But you find that A out of B equals to C out of D is still equals to K. But I can express it in this form. I add the numerators, that A plus C all over B plus D, but still it will give me a K. So this is very, very, very fine. So let's try to work out this, like a combination of an equation of a plane and a Cartesian equation of a line simultaneously to get the values of the unknowns. So let's have our first example. So by ratio theorem, I know that this is going to be x plus 4z plus y plus z plus 3x plus y all over. This is going to be 4 plus 6 plus 5. This would be equals to, I'm going to have, this is going to be 4x plus 2y plus 5z all over. This is going to be 15. But if you look at even the upper one, so this equation is the same as this, and therefore I'm going to have 15 out of 15, and therefore I'm going to get 1. And therefore that means that for all the above expressions, they're all equals to 1. And therefore I'm going to come here and say that x plus 4z all over 4 is equals to 1. Y plus z all over 6 would be equals to 1 also. And 3x plus y all over 5 is equals to 1. Now, having done so, I know that if this is, so this is x plus 4z, which is equals to 4. And I'm having y plus z equals to 6. And I'm having 3x plus y is equals to 5. So having done so, now let me work out these equations each to one another. And therefore, if I have x plus 4z is equals to 4, and I'm having y, z. So in this case, I can decide to eliminate z and remain with xy, such that I can work out with the third equation. And therefore, I'm going to have here, I'm having y plus z equaling to 6. So out of that, I know that if I'm to work out, like, let me take this as 1, 1, 1, and this as 2. So let me use substitution. So I know that from 2, I know that y would be equals to, but I cannot use substitution because I want to eliminate. So out of that, so if I have this, now I multiply this by 1 and here by 4. Therefore, I'm going to have x plus 4z, which would be equals to 4. But 4y plus 4z would be equals to 24. Therefore, to eliminate z, I would subtract. So this would be negative 3. No. This would be x minus 4y, which would be equals to, this would be negative 20. So this is another equation that I formed, for example. So out of that, I relate this equation with the other one. So I'm going to have something that's going to be 3x plus y, giving me a 5. At the same time, I'm having x minus 4y, which is negative 20. Now, this time, let me eliminate x. Therefore, I'm going to come here. I'm going to multiply down here by 3 and here by 1. So I'm going to come here and say that this is going to be 3x plus y equaling to 5. And here I'm going to have 3x minus 12y is equals to negative 16. Yes. So having done so, I come here, I subtract. I'm going to have 0. So this is going to be 13y, giving me a 5. 5 minus that. So this is going to be 65. Divide by 13. Divide by 13. So y would be equals to 5 in this case. So having got so, now let's go back and substitute so that we can get for other values still. And therefore, to get for the value of y from this equation, remember I got this from here, I got this from around here. So I'm going to do that. I can get for the value of x. So out of that, I know that x minus 4y is equals to negative 20. And therefore, so this is x minus 20 is equals to negative 20, and x would be equals to 0. Awesome. And now let's get for z. For z, so z we can get it from there. Therefore, if y plus z is giving me a 6, that means that, and I have y, which is 5. 5 plus z is equals to 6. Yes, and z would be equals to 1. So this is how you can use Rasho's theorem to work out. It's like a Cartesian equation of a line and an equation of a plane. So out of that, this is the pathway how you can go through it. And therefore, but this method does not apply to all, where you will use ratio theorem everywhere. So you find that there are places where this method does not apply, of which if this method does not apply, I'm going to be giving you a different method how to work out using ratio theorem. So out of that, let's go jump into the second method. Now for this one, you found that if you try to use the ratio theorem, that x plus y plus 2 plus z minus 1 all over 5 plus 2 plus 4, that this would give you something like I would have x plus y plus z plus 1 all over. This would be, I'm going to have 9, 11. See? So this has not even relationship with this. You find that you're getting totally something very different from what you're having here. So here ratio theorem does not work. So an appropriate method that works for all, even the first example I gave, would be this. So a universal method that works for all is this one. Now get this Cartesian equation, yes, and say that if x out of 5 is equals to y plus 2 out of 2 is equals to z minus 1 out of 4. Make the whole of this equals to a constant, let's say lambda. So having done so, now express all of them in terms of that lambda. So let's say x out of 5 is equals to lambda. So that means that this is going to proceed by saying that x is equals to 5 lambda. Now, if I have y plus 2 out of 2 is equals to lambda. So that means that this is going to be y equals to 2 lambda minus 2. Now for z, if I have for z, of which z minus 1 all over 4 is equals to lambda also, that means that z is going to be equals to 4 lambda plus 1. So out of that, having done so, now come into the second equation. Now this is our second equation. This was your first one, and therefore write it down and say that I'm having 3x plus 4y plus 2z is equals to 25. Now you come here and say that I'm having x, of which 3 into 5 lambda plus 4 into y, I had a value of which was 2 lambda minus 2 plus 2, of which z is 4 lambda plus 1, close this, is equals to 25. And therefore we are going to have 15 lambda plus 8 lambda minus 8 plus 8 lambda plus 2, which would be equals to 25. And therefore we are going to have 15 lambda plus 8 lambda plus 8 lambda minus 8 plus 2, which would be equals to 25. And therefore we are going to have something here of which this plus this, we are going to have 23, and then this would be 31. 31 lambda. And then this would be minus 6, which would be equals to 25. And then 31 lambda would be equals to 25 plus 6. And lambda would be equals to, this is going to be 31 divided by 31. And lambda would be equals to 1. Now, use this to find the values of x, y, and z, of which for x was equals to 5 lambda. And therefore, that means that x would be equals to 5. Now, at the same time, I was having y that was equals to, we had y which was 2 lambda minus 2. So we have 2 lambda minus 2. And therefore, this would be 2 minus 2, getting us a 0. Now, for z value was equals to, z was 4 lambda plus 1. We had 4 lambda plus 1. And therefore, this would be 4 plus 1, which was 5. And therefore, this is how you work out the like using the ratio theorem. It is quite very simple and very easy to use. Thank you for watching. If you like the video, give it a thumbs up. Don't forget to subscribe and always click notification. See you next time.